And now I request Mr. Vikram Maurya sir to kindly take over the session and start with it, sir. Please.
Okay, thank you, Swati ma'am. Is my screen visible?
It is visible, sir.
Okay, then. Okay, good evening, everyone. Today is our tour of this hands-on session for this frequency selective surface FDP. So in yesterday we are saw a various thing about the metamaterial. Okay, so we are till now we are covered how to design a structure in CST. Then we will cover basic part of the CST components, like from where we have to design and where we have to simulate, what are the boundary conditions, and how we can simulate a metamaterial. And clearly we can saw why the metamaterial is shown like a permittivity and permeability concept, whether only permittivity is negative or permeability is negative, and how we can achieve this in CST. Okay, so for this FDP further, today we have to design a absorber. Okay, because I already told you in the series of this FSS, metamaterial, then absorber, then polarization converter, then based on this unit cell structure, we can create a meta surface, and then the bending of you can say it as a meta surface, or you can say a array of these unit cell structure. And finally, and then we can observe the bending analysis, which we can call as conformal absorbers or PCR. Okay, so today we will start our session by designing a triple band terahertz absorber. The as you can see, this is the paper. This is one of my paper, which is the topic of this paper is triple band terahertz absorption based fractal ring shape ultra thin mustard oil adulteration sensor. The thing, this is mustard oil adulteration sensor. It's the application of sensing part. So we will not cover these things in our FDP. Our topic, our focus is only this thing, triple band terahertz absorber. In the previous session, we are designing a metamaterial on the gigahertz frequency range. Okay, that's why we are taking all the dimensions in millimeter. But today I have designed one triple band terahertz absorber, which is a terahertz. So the frequency band, so the dimensions are in micrometer. Just remember these things. All the dimensions are in micrometer and the frequency is in terahertz only, and the bands which I am covering in this designing process is triple band. So the complete session is going like, first we will design this terahertz band absorber. Okay, second we will discuss its frequency band and its boundary conditions, how we will assign the fluctuate port boundary for a unit cell structure, and if we have some time, then we will make a array of a 3x3 structure. Okay, I will show you the how we can design this 3x3 array, or if you want to design a 5x5, you can, and how we will employ it. We cannot create, we cannot put here a fluctuate port. We have to make a waveguide port here. I will show you. Then we simulate this structure. After designing and simulating this structure, we will see all the results which are necessary for the absorption point of view. Like first we will see the S parameters, in which we have to see the reflections and transmission coefficients, because we already know in absorbers we have to reduce the reflection and transmission coefficient so that we can get a unity absorption. Okay, so for the reflection, we will take care the impedance matching concept, and for the transmission, we have to take care the skin depth concept. Okay, then after this S parameter, we have we have to make a absorption formula, and by using this formula, we can observe the how much absorption this absorber achieves. Then we also see the impedance matching. What is the impedance of the what is the effective surface impedance of this absorber? Means if we are calculating the normalized, I will see all the formulas also. If we calculate the normalized impedance, then we already know the impedance is a complex term. So the impedance is having its real and imaginary part both. So for absorption, what uh, what are the values it have, we will see later. Then we will also see the theta variation and phi variation, how we can check the angular stability of any absorber. In the angular stability, we have two parameters. One is incident angle variation, and the second one is polarization angle variation. Okay. Then after for the then after we will also see in 2D and 3D result the E field and the surface current, how the structure behave at what resonating frequency, which resonating structure is responsible for that uh, absorption, that we can observe by the E field and surface current observation. And we can also see the parametric sweep, how we can optimize these dimensions, what concept we are using, and what results we have to take care. Like in any results, there are peak absorption value, and the frequency value, and the FWHM value, a how much the a greater than 90% bandwidth, that all we are covering in this. Okay, so first I will see the structure of this triple band absorber. Don't think about this second one, because this is a side view of absorber as a sensor. Just this one, the first one, structure A is the front parametric view, which have there all the dimensions, and the dimensions value are already written here, which we will use for designing our absorber structure. And this is the side view of this absorber structure. Okay, what is the thickness of this ground, then what is the thickness of this substrate, and this resonating structure, how it's look like. And the kz direction is the wave incident of wave direction, and then this x-axis is for E field, and this y-axis is for H field, that is shown here. And this is phi 0, this is clearly shown. Ex, this is phi 0, and this is theta is equal to 0 degree. That means wave is normally incidenting on the top surface of this absorber. Okay, when we are shifting this to 10 degree or 20 degree or 30 degree or 50 degree, 50 degree, then this is called as the incident angle variation. Okay, this is the basic step by step designing stage. See, what type of ring is it? Initially, this is the first one is a circular ring, and then in this circular ring, we have edged out some part of a hexagonal patch. So it is the ring is the outer side of that ring is a circular ring, and the inner side is as a hexagonal ring. Okay, like that, three similar three steps we have to follow to get the final absorption of final design of this absorber. Okay, there are first I will show you there are two options. One thing is first you will design the this circular shape. Okay, suppose this radius is r1. Okay, the first way is you have to design this circular patch. Okay, and then design a hexagonal patch and subtract it with this this patch. So you will get this thing. Okay. After that, in step three, again I am creating a circular patch having a length, having a radius of R3. See here, A1. This R3. And then I will cut a hexagon patch having a side length because this hexagon the the side length of this hexagon or we can say a radius of this hexagon, both are a similar thing, so don't confuse it. You can choose the radius or you can choose the side length, both are the same thing. So the means my point of I just want to say that from step 1 from step 2 to step 4 the process is go like this only, or if you know the exact parameter, suppose um, if the scaling factor is same, then you can directly make a copy of this step 2, and in the CST there is the option of scaling. You can directly scale down this step 2 version and put it in the center of here only. Okay. Okay, we can directly go to CST and design this thing. The basic part you already know, that's why I am designing these things in a quick manner. Here we have to change this thing. Dimension is in micrometer, frequency is in terahertz. No need to change anything. Right now I just put this value, we can change it. So the basic ground part and the substrate part is similar, which I've done earlier. So I'm not wasting time for this thing. Just see the value of this. The A value is 10 micrometer. Okay. A is 10 micrometer, TG is 0.035, TS is 1.54 micrometer. Okay. This is ground. Okay. The square ground and substrate is there. That's why the value is same, 0.2 Ag. Now in terahertz, the metallic part is gold, not copper. K is 10. Okay. I just remove this boundary box. Again, go to modeling, then brick, substrate, Zmin is Tg, Zmax is Tg plus Ts. The substrate is polyamide. In the previous lecture, when we are making a metamaterial for gigahertz, then we are choosing a FR4 substrate. Here, we are using this polyamide. Okay, review. This TS value is 1.54 micrometer. Okay, both the things are completed. Okay, now what is our third step? Now the rectangular and square you can create from brick only, but the circle you have to create in cylinder. Okay, go to the cylinder, cylindrical shape, choose this cylinder, outer circle. Okay, if our inner side is also a circular one, means a circular ring shape structure is there, then directly we can give a R1 and R2 center. X center, Y center is 0, 0 only. Tg plus Ts, Tg plus Ts plus Tg. Segment is 0 because for a circle we choose this segment 0. This is material gold. I am putting outer radius R1 and inner radius R2. Okay. What is the value of R1? 4.9. If I am putting this value is 4.9 and R2 is 4.9 for a circle, then everything will cancel out. I'm just putting some value so that I can show you what I want to display here. Suppose R2 is 0.8. This is the circle. Okay. Having a thickness of, this is the complete circle. The outer side and inner side both are circular, having a thickness of 0.1 because the outer radius is 4.9 and the inner radius is 4.8. But right now I don't want to make a circular ring. So my inner radius should be 0. That at that part, in this time, this will make as a patch. Okay, R1 and 0. Review. This one. Now the next thing is make a hexagon. So again, go to this cylindrical, go to this cylinder, outer hexagon, radius R2, inner radius 0 because I just want to make a hexagonal patch. Center is 0, I just copy this thing. Okay, now here the segment should be 6 because I want a hexagon. So I put this segment as 6. Material is gold only. Preview. Okay. Just take this outer circle, go to this boolean, subtract, outer hexagon, enter. The first part is completed. Just save this. Okay. Now the similar process we have to check for this. What is the value of R3 and R4? R3 is R3, which is the radius for this circular ring, and the R4 is the radius of this hexagon ring. 3.8, 3.4. Okay. And the thickness is same, 0.035. Mid circle, R3, inner radius is 0. Okay. Segment is 0 because I want a circle. Review 3.8. Okay. This is done. Fourth. Now this mid hexagon. Okay. R4, TG plus TS, TG plus TS plus TG. Now the segment is 6. R4 is 3.4. This one. Okay. Now choose this mid circle, subtract with this mid hexagon. Second part is completed. Now the third one is third circle radius is 2.6 and this hexagon is 2.3. 2.6 and 2.3. Again go to this cylinder, escape, inner circle. R5. Segment is 0. 2.6. 2.6 and 2.3. 2.6. Okay. Again go to the cylinder. This is the final part for the designing. Inner hexagon. Radius is R6. Two point three. Okay. Inner circle. Subtract. Inner hexagon. Now the designing part is completed. Okay. This is the complete designing of this. Now we can simulate. See, this is the result for step-by-step absorption process, which in every stage, whenever I am designing this absorber, in every stage you have to simulate it so that you can get all these steps. But whenever in the first step, if you in first step only, if you simulate this by applying the boundary condition and fluctuate port, and some result will come like this black one results, this you will get. Okay, but when you change the structure of this from step 1 to step 2, then that result will remove from this est library. Okay, that's why in every step you have to take the results for all these steps. Now in this case, directly we achieve the final results. For that we have to apply the exact frequency and the boundary condition for the case of absorber. Just a minute, there is a network issue. मैं तो AI setting.
Sir, you can unmute yourself if you want. Dear participants, there is a very important announcement that due to the immediate light cut, power cut in our department, the CST server cannot work right now. Therefore, the today's 1.5 session, because out of the 2 hours hands-on session, 1.5 hour is remaining. So 1.5 hour of the remaining session will be covered in next 2 days. Also, there is a slight change in the schedule. Tomorrow, the first session will be the technical talk from 9 o'clock to 10:30. Then, very important, that hands-on session will be from 11 a.m. to 2 p.m. The hands-on session will be there. And third session of tomorrow's, that will be from the 4 o'clock to 5:30. That will be the technical session. And also, whatever I am announcing, I will write down in this chat box as well as in the WhatsApp group, so that you can just revise it and listen to it once again. Vikram sir, if anything important I am missing, you can kindly add to it.
No, ma'am, no. Everything will cover.
Okay, so
We are
participants.
just taking the 2 hour session in tomorrow, 11 to 1. That is the tomorrow session, and the uh, remaining 1 hour for the compensation of this lecture.
Okay, sir. And for the convenience of the participants, I am writing in the chat box also, and will update in the WhatsApp group also.
Yes, we are also updating all these things in WhatsApp group. So you can kindly join tomorrow on time.